Welcome to this lesson for grade 9 math on geometry. And we don't do a ton of this stuff, but this is one lesson that I'm going to throw in here with the sort of geometric shapes and stuff. So um, basically, I'm going to go through a bunch of theorems, they call them. And theorems are sort of like uh, concepts or ideas that exist in geometry that you should be quite familiar with, okay? And a number of these will not be that difficult. The biggest challenge sometimes is just remembering the acronym that goes with them. And when I mean acronym, I mean like these little things like SAT, Supplementary Angle Theorem, CAT, CAT, Complementary Angle Theorem, and knowing which one applies in which situation, okay? So I'm going to explain each of them and then do an example that's off to the right-hand side of the page. So this basically, supplementary angle theorem is based on the concept that any straight line has a total of 180 degrees, and that's something you probably already familiar with. So if we divide that line with another line, or even if we draw it right through, doesn't matter, I'll maybe draw that a little neater, but just going to be a little messy here, apologize. So draw it through like this, then x and y would have to equal 180. So if we add these two up, that means this is going to equal 180 degrees. And that's pretty straightforward. So here's an example over on this side. I say if this angle is 64 degrees, then I would take my 180 and I would subtract 64, and that equals 116. So therefore, y equals 116 degrees. And then we often write in brackets y. What theorem is it that allows us to do this? And it's supplementary angle theorem. So that's the first theorem that we come across, okay? So then we'll move down to the next one, which is the complementary angle theorem. And this particular one works on the same premise. So if I draw a right angle triangle and I say this is right angle, we know that this angle is 90 degrees. And so if I draw a line in here and I have a value here, x and a y, these two must add up to 90 degrees. And so x plus y, I don't know, you could write that out, x plus y equals 90 if you wish degrees. And we can use this in our example and say that this is a 90-degree angle. You have to have some sort of symbol here indicating that it's 90 degrees, which is drawn there. And 57 degrees, so I would take my 90 and I would subtract 57 degrees, and that would give me 33. So x equals 33 degrees, which is the answer. And then if you're looking for the reason, it's CAT, cat, okay, they CAT. And then we come to some more theorems. One that you're very familiar with already, I know because we've talked about it, is that if I have three angles inside a triangle, x, y, and z, that x plus y plus z equals 180 degrees. And I think I had a watch a video there with Dr. Lee, and or Mr. Lee, and he showed you by cutting the corners out how that worked. And so this allows us to also calculate the angle of any missing angle if we have the other two angles in a triangle. And so this particular one here, if I go over here, I can say this is 180 minus 108 minus 42, okay? And so that's like, I believe that works out to 40. Let me just double check because I've been known to make some mistakes here. So 180 subtract 108 subtract another 42, and that equals, oh, there you go, 30 degrees, not 40. So good thing I did that for a second, okay? 30 degrees. So we can say Z equals 30 degrees. And the theorem is called the sum of the angles of a triangle theorem, and it's SATT, not to be confused with SAT, which is supplementary angle theorem. So you have to have that extra T in there to be getting the correct mark for saying the correct theorem, okay? All right, so we'll move down and we'll look at what's called the opposite angle theorem. This is pretty straightforward. If two lines intersect like this, Okay, so we have two lines that intersect. This angle will always equal this angle. So x and x will be equal, y and y will be equal. And that's a pretty straightforward understanding. So in this particular equation, I have two. A is 151 degrees because of opposite angle theorem. And then I can also say B, and B is going to equal, well, it's going to equal 180 minus 151, which I believe is 29, and that is correct, 29 degrees, just double checking with my calculator. And I would then say this is supplementary angle theory because I'm using the fact that this is 180 here or across here. It doesn't matter which way I'm going. From A and B have to be 180 as well as 151 plus B have to be 180. All right, so that's called the opposite angle theorem. And then we can move down and get a couple more of these. We get the Isosceles triangle theorem. Okay, so isosceles triangle I should probably have here, and I have to indicate that it is in fact an isosceles triangle theorem. So when we do an isosceles triangle like this, if these two sides are equal, then we know that these two angles are equal. Okay, and that is the isosceles triangle theorem. So in this one, I might say x equals 78 degrees, and it's ITT. That's telling me that the isosceles triangle theorem is working to my advantage in this case. Okay, and then here we go. We have our parallel lines theorem. And there's a couple of them, a C pattern and a Z pattern. Sometimes the C pattern can be called an F pattern as well, if you wish. Okay, and what they're saying here is that if you take this here, x and y, x plus y will equal 180 degrees if these two are parallel. And these little hash marks, they indicate parallel lines. So if this is an x, that's a y, we get what's referred to kind of like a C pattern. Now, sometimes people look at it and go, well, that's really like an F pattern. So they'll say, you know, the F pattern can apply here, but it doesn't matter to me. F pattern, Z pattern, C pattern, I don't care. It's mostly the fact that it's the parallel lines theorem. And so this tells me that this is 180 here minus 60, and I think I can do this without a calculator. That's 120 degrees. And the reason would be PLT-C pattern, okay? And then sometimes, yeah, don't worry. Just PLT would have been acceptable. If you put C or F or Z, I don't really care. It's just a sort of a sample that you're looking at. Okay. All right. So if we go down, the Z pattern is basically saying that there are certain situations where when we have a parallel lines like this, okay, I'm not the best drawer, so apologize for that, that this particular uh, X and this Y are equal, or sometimes they, yeah, in this case, they are equal to each other. And you could also go with like M here and N here, doesn't matter. So X equals Y or M equals N in this case. So these two angles and these angles are equal. And so in this particular case, Y is going to equal 47 degrees. And the reason is the parallel lines theorem, and it's the Z pattern. And again, like whether you put the Z, C, or F or whatever, I don't really care whether that's there. I'm mostly, you understand that it's because of parallel lines that we get those unique rules. So we can do a sample question. Um, not sure why. Oh, I know why. It thinks I'm in French, so samples were spelt wrong. All right, so here's a sample question. Whew, look at that. We can do all kinds of stuff. And for each one, we can get an answer, and then we can state the corresponding theorem. So for example, A, if I want to do A here, A will be 180 minus 112, okay? So 180 Something's gone weird on my calculator here. It's in stat mode. There we go. Back to home. Okay, so 180 minus 112, and that equals 68 degrees. So I can write in my answer 68, and then I have to say why. Well, that's the supplementary angle theorem, SAT. Okay, and I can do the same for C, and you could say C is 68, or sorry, C is 68, and you could say that that was opposite angle theorem, but I prefer to see students use the supplementary because this is what's given, and so that makes more sense, okay? So the supplementary angle theorem again here. And B would be 112, okay? And the reason it's 112 is the opposite angle theorem because it's opposite 112. So 112 and then OAT. You don't have to put them in brackets. I don't know. It's a habit of mine that I always put the theorem in brackets behind because it's sort of like, just an add-on. But if you just want to write it in full, you can. Now, once I'm here, I can then jump across and go, oh, look at this. This is an isosceles triangle because of these two hash marks. So therefore, D must equal A. Therefore, A and D are the same. And so that's 68 degrees. And that's ITT, okay? Isosceles triangle theorem. And then I can quickly jump and do E, which is obviously 112 degrees because it is supplementary to D, supplementary angle theorem. So we got 112 SAT. Wow, we're getting just flying all over the place here, right? So then I want to do F. Well, how the heck do I do F? Well, I can get F because I know this is 68 and that's 68. Therefore, I can take 180 and I can subtract 2/68 from that. So I go 180 minus 68 and then minus 68 again. And what I'm doing is I'm using what is called the sum of a triangle theorem. So that is 44 degrees. I did the math on that. And it's SATT. Okay. And then I can find G going right across from it. Well, G is also going to be 44, and that's opposite angle theorem. And then I can find H because H is adding these two together, supplementary angle. So that will be 44. I'll take the, I'll take 180 and subtract 44 to get H, and that's 136 degrees, and that is supplementary angle theorem. And we've now basically solved all the ones here. Now we got to start figuring out what the heck is going on here. Now I do notice that I have a couple of parallel lines. These two lines are parallel, and these marks tell me that. And I have 136 here. And I'm not sure I have anything I can find here, but I might note that this is 68 right here because it's equal to D. Now there's no letter there. It's not asking for that, but that might come in handy because that'll give me, another interior angle here, okay? Now, I can move around and do another question here, and I can go 136 plus K that's a C pattern. See the C pattern right there? That there is a C pattern. So K should be add to 136 to give me 180. So I can take that and go 180 minus 136. Well, K equals 44 degrees, I believe. Let's just double check. 180 minus 136 equals 44. 44, and that is parallel lines theorem. And if you want, you can throw the C on the end. Now I can get J. J is going to be 136. Now I can also say this by parallel lines theorem if I want, or I could do it by supplementary angle theorem, either way, because if I know this is 44, then I can subtract Either way, it's going to be 136 degrees. And I'll just say supplementary angle theorem or a PLT version. Take your pick. It doesn't matter. Parallel lines theorem. Now I have 68 here. I have 44 here. I can calculate M using the sum of my triangles. So let's work on that one. Sum of my triangles will be 180 minus 180, subtract 68, and then subtract another 44, and that will be the sum of the three angles inside this triangle. And son of a gun, if it doesn't work out to 68 again. So that tells me 68, that is sum of a triangle theorem, TT. Make sure you got your two T's on there, not SAT. And that also tells me if this is 68 and this is 68, this length must be the same as this length, okay? And it's not asking for that, but it's just interesting to find out, okay? Now, we can go to get N. N will equal M. It has to because of opposite angle theorem. So that's 68 degrees, OAT. And we now have this at 68. I sometimes like to write them in here because it helps me envision and see what I need to do, okay? All right, so we have P, Q, and R left, and that's it, and then we're almost done. So R we can do by supplementary angle theorem from 136. So again, 180 minus 136, and I believe that's going to be 44 again, and it is, so that's 44, and it's SAT, supplementary angle theorem, that tells us that. Now we have 44 here. That tells me that this here must be adding up to 180. So again, it's 180 minus 68, subtract another 44, because the sum of the three angles of a triangle have to equal 180 degrees. So that answer works out to 180 minus 68 minus 44 works out to 68 degrees. Oh, I got the answer for R in the wrong place. That's my bad here, folks. Erase this. The answer for R should have been down here by R. SAT. And P will work out to 68 degrees. And it is the sum of a triangle, SATT. And then the last one is Q. So if I know this is 68, it's 68 minus Q, which works out to 112 degrees. So just double check that, 180 minus 68, and in fact it is 112 degrees, SAT. And there you have it. You have a whole whackload of, it just keeps developing and moving on. You do start to see the same numbers over and over again because there is connections between those angles, and that's interesting to see. There's a couple worksheets for you to practice some of this on. Don't get too caught up in it. It's not maybe the most important thing in grade 9 math, but it is an interesting little activity. Some kids really like this, so I hope you enjoyed it. All right, we'll see you next time.